So, what is a scientific theory and what is a hypothesis? These are terms that are thrown around a lot. Lots of people use them in everyday conversation. Like my theory about what happened last night was the following, or something. And there's actually a very specific kind of definition for both theory and hypothesis when we're talking about scientific theory and scientific hypothesis. So a scientific theory is an organized system of ideas that explains a wide range of observations of a natural phenomenon of interest, while a hypothesis is a specific statement of expectation, to explain a far narrower set of phenomena, typically, that are derived from a theory. Scientific theory accounts for diverse observations. It proposes sort of like a model that can tie them all together. It's an explanation for a large number of findings in the natural world, including the psychological world. It's the best explanation we have, until competing evidence comes along that sort of, dismantles it, right? But scientific theories must do more than account for existing data. They should also be able to generate predictions regarding new data that we haven't yet observed. For a theory to actually be scientific, it must be capable of generating novel predictions that researchers can then test. So these testable predictions are the hypotheses, right? And theories are sort of general explanations, while hypotheses, again, are specific predictions that are derived from these explanations. And there's a number of very good definitions, actually, that have been put forth by, for example, the American Academy for the Advancement of Science, which says, scientific theory is a well-substantiated explanation of some aspect of the natural world based on a body of facts that have been repeatedly confirmed through observation and experiment. Such fact-supported theories, they write, are not guesses, but actually reliable accounts of the real world. And from the U.S. National Academy of Sciences, the formal scientific definition of theory is quite different from the everyday meaning of the word. It refers to a comprehensive explanation of some aspect of nature that is supported by a vast body of evidence. Many scientific theories are so well established, according to the U.S. National Academy of Sciences, that no new evidence is likely to alter them substantially. For example, no new evidence will demonstrate that the Earth does not orbit around the sun. That's heliocentric theory. Or that living things are not made of cells, including, the brain, right? That's the cell theory. That matter is not composed of atoms, or that the surface of the Earth is not divided into solid plates that have moved over geological timescales, which is the theory of plate tectonics. One of the most useful properties of scientific theories is that they can be used to make predictions about natural events or phenomena that have not yet been observed. And then there is the oldest, kind of scientific society, in the world, which is the Royal Society in the UK. And their motto is, actually, I like this a lot, nullius in verba, which is Latin for take nobody's word for it. Authority does not equal accuracy. So you need to actually, even scientific authority, you need to challenge it. You need to come up with an experiment, that shows that predicts a different outcome. And if it doesn't fit, well then, and it's replicable, it's doable, right? It's falsifiable. Well then, you got something going there. Then then the theory may have to adjust to incorporate, these new findings. So what the Royal Society says about their motto, nullius in verba, or take nobody's word for it, is it is an expression of the determination of fellows to withstand the domination of authority. And initially they were talking about sort of ecclesiastic or church authority, and to verify all statements by an appeal to facts determined by experiment.